and estimating square roots. So first off, we need to talk about what it means to square something and what it means to square root something. And that is all related to exponents. An exponent tells you how many times to multiply a base by itself. So when I see this, that is saying I'm going to take this base number, the 2, and multiply it by itself 3 times. We call the small raised number the exponent. That's 3 here. We call the big number our base. That's 2. So that's saying we're going to take 2 and multiply it by itself 3 times. That's the expanded form, really just showing the multiplication. 2 times itself 3 times. The simplified answer is just actually doing that multiplication. That equals 8. 2 times 2 times 2. This is a picture of the Desmos calculator. So you see here we have an exponent of 2 and a base of just a. That's implying that you could put anything in that base. So you could say 3 to the second power or 9 to the second power. The one right beside it, that has a base of a and then an exponent that says b. That means we can change either of these numbers. So we can use a base of 9 and let's say an exponent of 4. This lets you type any base with any exponent. This one lets you type any base with an exponent of 2. The 2 right below it are called square roots or cube roots or really nth root. That's how we would say that. But for the most part, we're going to be sticking with just square roots. That's this one. That's saying we're going to look for the number that's multiplied by itself to give us this number. That's what a square root essentially is. This number came from a number that's multiplied by itself. That number here would have to be 3. So a square root works backwards to figure out what number was multiplied by itself to give us this number. So you have access to that in your Desmos calculator, but you have to know how to use the calculator. So looking at these 3, you could think all 3 of those are the same, but they're actually all different. If you evaluate this in your calculator, type this exactly like you see it, negative the 3 in the parentheses with the exponent on the outside. I'm going to show that in Desmos just so you can see it. Negative 3 inside the parentheses with the exponent on the outside. And you can see that gives us negative 9. So here we're just going to write that our answer was negative 9. Below it, I'm going to explain why. That exponent is only affecting the stuff in the parentheses. If the negative was inside the parentheses, then that would be affected by that exponent. But right now, that negative is on the outside of the parentheses. This exponent only affects the stuff in the parentheses. So the negative will just sit on the outside and wait for the next step. The exponent is really our first step. If you can think of this as order of operations, this is really like multiplying by negative 1, where this is an exponent. So we evaluate the exponent first. That would be 3 times 3. It's just squaring a positive 3. So we do 3 times 3. The negative just comes down to the next step. 3 times 3 is 9. The negative follows, giving us just negative 9. Using that same logic, the exponent affects everything inside the parentheses. So this is actually saying we're going to take that whole thing and multiply it by itself 2 times. Negative 3 times, oops, that's supposed to be a negative sign. Let me try that again. Negative 3 times another negative 3. That negative is included in the multiplication because it's inside the parentheses. So we probably don't need Desmos for this, but I just want to show it. Negative 3, where the negative is inside the parentheses squared. That's negative 3 times negative 3, so it gives us a positive 9. The last one has the parentheses on the outside. It's really similar to this first one. That 3 is the only thing affected by the exponent. Even though this seems like we're squaring negative 3, it's actually kind of the same thing as what we showed before. It's, I guess I should write that below. It's negative 3 is the only thing getting squared, not the negative sign. While it's in the parentheses, the exponent is on the inside of the parentheses too, so the 3 is the only thing affected by that exponent. We do 3 times itself, and the negative sign kind of just comes along with this. That ends up as a negative 9 also. And I will show that in Desmos just to prove it to you. That's also -9. So you really need to know how to use Desmos and how to carefully type these in to make sure that you're actually evaluating what's being given to you. Whoops. All right, so these are the list of perfect squares 1 through 400. This is a perfect square, this is a perfect square, this is a perfect square, because a whole number multiplied by itself gives you that number. These are the perfect squares, because you can multiply a number by itself to give you that number. Right. When you take the square root of a perfect square, like 25, you're always going to get a whole number. Square root of 25 is 5. Square root of 121 is 11. 121 is a perfect square because when you do the square root of that number, you get a nice whole number. If you get a decimal, that is not a perfect square. So if you did the square root of 10, that would give you 3 point something. It doesn't matter what that is. We know that 10 is not a perfect square because this is a decimal answer. These are inverse operations of each other. We're going to talk about this a lot with equations, but when I say inverse, I really just mean they're opposites of each other. When you square something and you square root it, those are doing the exact opposite. This is multiplying it by itself. This is figuring out what number was multiplied by itself to give us that number. The phrase square root literally comes from the picture. It's actually a square with a perfect number, a whole number of squares on the inside. When that happens, this side length will represent the square root of that number. So the square root of 81 is 9 because it's literally measuring the side length of that square when we have 81 blocks in here. The square root represents the side length of the square. All right, when we're estimating square roots, it helps to know some perfect squares, but it's not essential that you know them. It's definitely going to help. So this is one strategy to figure out where this perfect square lies between which two consecutive whole numbers is the square root of 33. When I say consecutive whole numbers, I mean two numbers in a row. 3 and 4 are consecutive whole numbers. 101, 102, those are consecutive whole numbers, just back to back, one after another. So one way we could do this is think about the perfect squares that surround this. What perfect squares are on either side of it? Well, I know that 25 is a perfect square, and 36 is another perfect square. Those are the two that are closest to it on either side. One is smaller, one's bigger, but there's no other perfect squares that are in between. So if I do the square root of 25 and I do the square root of 36, the square root of 33 will have to end up in between there. Square root of 25 is going to be smaller, square root of 36 is going to be bigger, but I know the square root of 33 is going to end up somewhere in there. So I could take the square root of this, take the square root of that, and figure out that the square root of 33 is somewhere in between 5 and 6. Second way you could do it, this is probably going to make more sense to a lot of you, just use the calculator. Take the square root of that number. We're going to compute the square root of 85. So we type this button and then put the 85 inside of there. It's 9.219. Let's just call it 9.2 because that's all I really need from that. 9.2. So actually our first step is calculate the square root in your calculator. We find out that the square root of 85 is 9.2. So to figure out what that's in between, you write down the number in front of the decimal, which here is just 9. In front. The second number is the next highest consecutive number. It's just the next number. That is a mathy way to say consecutive Sorry, my pen is lagging right now, but that is a mathy way to say just the next number, 9 and 10. So the square root of 85 is somewhere in between 9 and 10 because it's 9.2. It's a little bit bigger than 9, a little bit smaller than 10. All right, we're going to try a couple more, especially with these weird cases at the bottom. So square root of 27, I know that that is 5 point something. Actually, I'm going to do this with the first strategy. I know that's somewhere in between 25 and 36. So if I take the square root of 25, that's 5. I take the square root of 36, that's 6. I know square root of 27 has to be somewhere in between those. And I'm going to use strategy 2 for the next one. I'm going to take the square root of 72. It is 8 point something. So I know it's bigger than 8, but it's not quite up to 9. So it's somewhere in between 8 and 9. I'm going to go back to strategy 1 here just because I see this is right above 100, and I know 100 is a perfect square. So I know it's a little bit bigger than the square root of 100, so it's a little bit bigger than 10, but it's not bigger than square root of 11, or sorry, 11 squared. It's not bigger than 11. So it's in between 10 and 11. All right, actually, I think you can try these 3 on your own. You're going to take the square root of each of those and figure out which dot on the number line those match up with. We've got to talk about these last ones because these are special cases of square roots. So square root of 36, we know that's just 6. When we have a negative on the inside, you can try this in the calculator, but it will not be able to evaluate this. If we do the square root of negative 64, it's going to say that's undefined. Actually, that's not exactly how we want to say that in math. We're going to say it's imaginary. In high school, you'll learn about imaginary numbers. Don't know why this isn't writing, but I'm trying to write the word imaginary. Anytime we try to do the square root of a negative number, it will always end up as an imaginary number. We can't evaluate that when the square root's on the inside. Or sorry, when the negative is on the inside. When the negative is on the outside, that just carries over to our answer. So we do that square root just like normal. Square root of 81 is 9. The negative on the outside stays with it. That just ends up as a negative 9. Then we have this weird symbol. This symbol in front of the square root of 100 here is a plus and a minus sign. That's actually implying we're going to say it's both positive and negative 10. It's a positive version and a negative version of 10. And really the reason is because we can do negative 10 squared and we could do positive 10 squared and we would get the exact same answer. So when we do the square root, sometimes this is actually going to show up. Sometimes it won't, but actually there is an implied answer of negative 6 here too. You don't have to write this for now, but later you'll learn that this is actually a positive and a negative version of that number each time. We're going to go through each of these really quick. Square root of 289, I'm just going to do that in the calculator. That is 17. Square root of 361 is 19, but it has a negative sign out in front, so that's negative 19. Plus or minus, the positive and negative version of the square root of 49 is plus or minus 7. And then this one is imaginary. We cannot do the square root of a negative number. Not yet, at least. In high school, you'll learn about that. For now, we'll just call that imaginary. Hope this helps.